Yeah, here is question 6. It is given that tan theta equal to square root of 5 over 5 and the interval is given 180 to 360. Find the value of cos theta. So as we know the identity, because identity is given in the question paper, so the formula sheet. Okay, so secant square theta equal to 1 plus tan square theta, because there is a tan, so I'm choosing this. So secant square theta equal to 1 plus tan is given already, so root pi over 5 whole square, which is secant square theta equal to 1 plus, when I take square root, is become 5 by 25. So secant square theta equal to 1 plus 1 over 5. I simplified. So next, secant square theta equal to, I'll take LCM right side. So 5 plus 1, 6 over 5. So I'll get a secant theta. It's going to be plus or minus square root of 6 over 5. Okay, so next, yeah, this is secant theta. Now, see, this is the important one. Tan theta equal to root 5 over 5. So tan is the answer is the value is positive here. So the here 180 to 360. So this is unit circle. This is 180 to 360. So that means only third quadrant and fourth quadrant. But tan is positive only on third quadrant. So we are choosing only third quadrant because here only the tan is positive. Okay, the same third quadrant here secant is so I'll change into here secant is negative because cos is negative, so secant is negative. So I can choose only secant equal to, so negative value, which is negative square root of 6 over 5. So I'll change into cos is secant is 1 by cos. 1 by cos equal to right side also 1 by, so I'll make a swap. So I'll get square root of 5 over square root of um, 6. 1 by cos. So no, sorry, I didn't substitute because left side still I wrote no, 1 by cos. So I'll write here square root of 6 over square root of 5. Now I'll swap. So which is cos theta equal to, so everywhere you need to put theta, cos theta equal to negative square root of 5 over square root of 6. That is the final answer. Okay, the final answer going to be cos theta equal to negative square root of 5 over square root of 6. Okay, so next I need to find sin theta. So we know tan theta equal to sin theta by cos theta. So I want sin theta, so I'll bring the cos theta to left side. So cos theta into tan theta equal to sin theta. Okay, so just I'll substitute the value. Sin theta equal to cos theta. Cos theta value is negative root 5 over root 6 times tan theta. Tan theta already given, which is negative root 5, sorry, root 5 over 5. So numerator root 5 times root 5 is become negative 5 over 5 root 6. So here 5 got cancelled, then negative 1 by root 6. Okay, we can leave the answer, otherwise we can do rationalize the denominator. So I'm multiplying square root of 6 numerator and denominator, which is going to be root 6 over 6. This my sin theta. Okay, so next question, find the value of secant theta plus cos theta. Secant theta already we did it, which is, yeah, negative. Okay, secant theta plus cot theta equal to yeah, so I can write this one, secant theta plus cot theta is 1 by tan theta. Okay, so next I'm going to apply the value, which is negative square root of 6 by negative square root of 5 at times this is 1 by tan theta, so the tan value going to be swap, which is 5 by root 5, which is 5 over root 5. So yeah, this is plus. So final answer 5 minus root 6 over square root of 5. This answer is, so secant theta plus cot theta equal to 5 minus square root of 6 over square root of 5. That's a final answer for us. We need to give the answer as a plus b root c over root 5. So we got the answer. So instead of a's place 5 is there, and b's place -1 is there, and c's place, so a's place 5, b's place -1, and c's place 6. Okay, so let's go for the next question. Question 7. There is two equations given. One is curve equation, one is the straight line equation. So find the coordinates of A. Both equations are intersecting, so we can just solving the equation. Y equal to yeah, both are y equal to, so I can equate both the equations. Okay, 5 by x plus 1 plus 2 equal to 2x plus 1. Okay, so next, take LCM left side. 5 plus 2 into x plus 1 over x plus 1 equal to 2x plus 1. So here, expanding 5 plus 2x, yeah, plus 2 equal to 2x plus 1 times x plus 1. So here 7 plus 2x equal to, so here expansion 2x square plus 2x plus x plus 1. So bring everything to one side, so I'll get 2x square plus 3x plus 1 minus 2x minus 7 equal to 0. So next, 2x square, so plus x minus 6 equal to 0. Next I am solving, okay, so multiply time I need to get -12, and addition time I have to get +1, which is 4 and 3. So 2x square plus 4x minus 3x minus 6 equal to 0. So next, 2x square, so take 2x out, x plus 2, and yeah, so here also we'll write x plus 2, so we'll get -3 equal to 0. So 2x minus 3 and x plus 2 equal to 0, which is, yeah, 2x minus 3 equal to 0. So here x equal to 3 by 2, and we'll get x plus 2 equal to 0, so we'll get x equal to -2. So we got x value, so we are going, yeah, and we need to get y value. Okay, so this value, so I'll apply in the straight line equation. Y equal to 2x plus 1, so which is 2 into 3 by 2 plus 1. Here this got cancelled, so I'll get the answer as a 4. So next one, y equal to 2x plus 1, I'm going to apply here. Y equal to 2 into -2 plus 1, which is -4 plus 1, so it's -3. So the solutions are, the first solution is 3 by 2 comma 4, and the second one is -2 comma negative 3. Yes. Okay. So when we see the question, see this happening only the first quadrant. First quadrant there is no negative answer. There is no negative values. So this will be, we are not going to take this negative 3 and we are going to ignore this. So we are going to choose this. So the coordinates of A coordinates is going to be 3 by 2 comma 4. That is the answer for us. Okay, so the next one, yeah, it's done. Okay, the next one, find the exact area of the shaded region. So we are going to do integration here. So exact shaded region. Okay, so first I will take curve value. So this coordinate is 3 by 2 comma 4. Okay, so here to here, this is 0 for x, so this is 3 by 2. So we are going to 0 to 3 by 2. First we need to find under the curve. Okay, so I'm going to find this entire area. So this full area, first I'll find out this full area. Yeah, until here, this full area I'll find out. Then I'll subtract this area. So if I'll subtract this area, okay, so I'll get it only the shaded area. So below the curve minus below the straight line. So integration, the value is going to 0 to 3 by 2. See on the x-axis happening. Okay, so area equal to integral 0 to 3 by 2. So the curve equation should be first. The curve equation is 5 by x plus 1 plus 2. 5 by x plus 1 plus 2 minus the line equation curve 2x plus 1 dx. Okay, so next integration 0 to 3 by 2. So I'm just simplifying here 5 by x plus 1 plus 2 minus 2x um, minus 2x minus 1 is going to be, because we are going to subtract this equation. Okay, minus 1 dx. Okay, so next I'm going to uh, yeah, there is 0 to 3 by 2. So 5 by x plus 1, here 2 and minus 1 become 1. So plus 1 minus 2x into dx. Okay, now I'll integrate. Okay, first part 5 by 1 by x is going to be log x. So 5 into log x plus 1, and the second part is going to be x, and third part going to be minus 2 into x square by 2. The limits 0 to 3 by 2. Okay, the next 5 log x plus 1 plus x minus 2 got cancelled. It's become x square and 0 to 3 by 2. Next, I'm going to apply the limits. First, we need to apply the upper limit, which is 5 into log, okay, 3 by 2 plus 1 plus 3 by 2 minus 3 by 2 whole square minus the lower limit 5 log 0 plus 1 minus 0 minus 0. Okay, so here 5 log 3 by 2. So I'll take LCM here, 2 plus 3, 5 over 2. Then plus 3 by 2. So it has become 9 by 4. Okay, so this is in the bracket, this is the first part, then minus here, everything is the other part 0, 5 log 1. Okay, so here 5 log uh, 5 by 2, then plus I'm taking LCM here, so it become here's multiply by 2 multiply by 2, so 3 times 2 6, 6 minus 9, which is negative 3. Yeah, so negative 3 by 4. This is the first part. Second part, we know log of 1 is 0, so entire thing becomes 0. So here 5 log um, 5 by 2 minus 3 by 4. This is the final answer. So if it's calculator, we can get the remaining value. So this is a non-calculator paper, so we cannot go further. Okay, we have to stop here. That's the final answer for area. Okay, so the next question, question 8, going to be the first term of the geometric progression is 10. Okay, geometric progression, we know the formula is a n, the formula is given the formula sheet, so a r power n minus 1, and yeah, the first term of the geometric progression is 10, so which is gp, I'll write a equal to 10, and geometric progression for the positive common ratio, so the r is positive here, the ratio is positive. Okay, next one, the first term of the arithmetic progression is 10, and there is another AP is given now. AP, here the first term, here also A is 10, and here arithmetic progression is, so here D is negative is given, so negative difference, so D is negative. So arithmetic progression formula, so I'll take a sub, okay, a plus n minus 1 into D. Okay, so what is given? Okay, the second term of the geometric progression, so second term, it's same as the fourth term of the arithmetic progression, so what we can write, so a2 equal to, we can write as a4, which is going to be yeah, a2, how we can write, just substitute here the first equation, so we will write a2, first term is given already, 10 r power n minus 1, 2 minus 1 is 1, 10 r equal to, because a2 equal to, so 10 into r power 2 minus 1, which is 10 power r power 1, which is 10 r, so I put it here. Next a4, a4 just substitute here, a is 10, 10 plus 4, 4 minus 1 is 3, 3d. So here I'll bring it everything one side. So 10r minus 3d equal to 10. This is my first equation. Next I'll go for the second thing. A third term of the geometric progression. So that is a3 is same as sixth term of arithmetic progression. So which is a6. So the first equation, I'll make a square here. Okay, now the second part. Okay, a3 equal to a6 is given. The third term of the geometric progression is sixth term of the arithmetic progression. So a3 equal to a6. So I'll write the same way here, 10r square. 10r square, because r power 3 minus 1, which is 2, equal to a6, again 10, 6 minus 1 is 5, 5d. So here also I'll make it like a 10r square minus 5d equal to 10. So this is my second equation. Okay, so find the values of r and d. That's our question. So just we need to solve these two equations. Okay. From first term, I'm going to make the subject of d. So how to make it d? Yeah, from here I can make it. Okay, 10r minus 10 equal to 3d. 10r minus 10 by 3 equal to d. So this value just I substitute here, 10r square minus 5 into 10r minus 10 by 3, yeah, equal to 10. Now I'll expand 10r square minus 50r uh, plus 50. This is, yeah, plus 50 equal to, so here over 3 equal to 10. So what I'll get, I'll do this side. Okay. I'll take LCM. So left side 30r square, 30r square minus 50r plus 50 equal to 30. So 30r square minus 50r, I'll bring 30 this side, so it's become plus 20 equal to 0. So I'll divide the entire equation by 10. So 3r square minus 5r plus 2 equal to 0. So now multiply times 6, addition time negative 5, which is negative 6 and 1. So negative 6 and no, 3 times 2, so which is going to be 3 and 2. Yeah, 3, negative 3 and negative 2. Okay, so 3r square negative 3r negative 2r plus 2 equal to 0. So here I'll bring it 3r outside, so r minus 1, so r minus 1, which is negative 2 here equal to 0. So 3r negative 2 and r minus 1 equal to 0. The r value is going to be r equal to 2 by 3 and r equal to negative 1. So this r equal to negative 1 going to be reject, because the question is given here, the geometric progression has positive common ratio, so we cannot choose r equal to negative 1. So I got the r value. Now I'm going to um, yeah, I'm going to put it in some equation, so I'll get d. Okay, so yeah, 10 into 2 by 3 minus 3d equal to 10. So 20 by 3 minus 10 equal to 3d. So I'll take LCM, 20 minus 30 equal to 9d. So 20 minus 30 is going to be minus 10 by 9 equal to d. So that's the final answer. So I got the value r equal to, so this is our r value, r equal to 2 by 3 and d equal to minus 10 over 9. So that's the final answer for us. Okay, next, determine whether the geometry progression has a sum to infinite. Okay, there's a condition. So yeah, the condition going to be the absolute value of r should be less than 1. So our r is 2 by 3. So 2 by 3 obviously is less than 1, and the other r is going to be, okay, r is rejected, that's so it's less than 1. So next, our formula, sum of infinity formula is yes infinity, the formula sheet will be given. So a by 1 minus r, the r is going to be less than 1. So this condition is satisfied, so just apply the value here. So 10 by 1 minus 2 by 3, which is 10 by, take LCM, 3 minus 2, 1 by 3, which is equal to 30. So that's the final answer for sum of infinity. So sum of infinity is exists, so the value is 30. So final answer is Okay, next question 9. Question number 9. Log 2 of x plus 1 minus 4 log the base of x plus 1 2 equal to 3. Okay, so we need to solve x, we need to find out x. So log 2x plus 1 minus 4. Here I am going to make base is 2, so it's become log 2 power 2 over log 2 into x plus 1 equal to 3. Okay, so next step I'm going to do substitution. I'm taking let u equal to log 2 of x minus 1. Okay, so next I'll just substitute here u minus 4 into, because log 2 and 2 become 1, so just leave it. Okay, divided by u equal to 3. Now I'm taking LCM, u square minus 4 equal to 3u. Okay, next bring everything one side, u square minus 3u minus 4 equal to 0. Now yeah, it's like a quadratic, so the factors are minus, this is u, okay, minus 4 and 1. The factors are minus 4 and 1, so I can write u plus 1 and u minus 4 equal to 0. So the value is u equal to negative 1 and u equal to positive 4. Okay, so we substitute this value equal to log 2 of x minus 1. So first I'll put first value log 2 of x plus x minus 1 equal to, I'll put the first value is going to be 4. I'll take 4 first. Okay, so logarithmic to exponent, 2 power 4 equal to x minus 1. 2 power 4 is 416 equal to x minus 1. So x equal to 16. Here is log formula is x plus 1. Sorry, everything is plus 1. Here also is a plus 1. Here is plus 1, so everything is plus 1. So here also it's plus 1, so plus 1 plus 1, so x equal to 15. Next I'll put u equal to negative 1, so log 2 of x plus 1 equal to negative 1. So 2 power negative 1 equal to x plus 1, so 1 by 2 equal to x plus 1. 1 by 2 minus 1 equal to x, and I solve 1 by 2. Take LCM, 2 minus 1 is negative, 1 by 2 equal to x. Yeah, so yeah, negative 1 by 2 and 15 is the answer. Okay, now see, now we have to check both answer is possible or not. Log of negative is not possible, so here the log of x plus 1 is coming, so we'll check x plus 1 whether it's positive or not. So x plus 1 equal to 15, put x equal to 15, so we are getting 16, so it is possible is greater than 0, and another one, so x plus 1, okay, so x equal to negative 1 by 2, negative 1 by 2 plus 1 is going to be 1 by 2, so which is greater than 0. So therefore both the values are possible. The final answer, x equal to 15 and x equal to negative 1 by 2. That's the final answer, right?